source of energy that man has always relied upon, but has never fully realized, is the sun. Its power is free, its potential as a source of energy unlimited. And now, the chairman of the board of Contractors License School, Al B. Conahan.
Hello, I'd like to bid you a warm welcome to our introductory program on solar energy. We're going to be discussing the major working parts of a solar energy system, that of the collectors, the transfer mediums, the storage mediums, and talk about the distribution of solar heat. We're also going to be discussing the difference between an active system and a passive system. By the end of this program, you should have a solid educational foundation, which will greatly assist you in passing your state examination.
Throughout history, man has used solar energy, either indirectly or directly, to warm himself. In the 1920s and 1930s, solar water heaters were in wide use throughout California and Florida. In fact, the solar industry was booming in Los Angeles until cheap and abundant supplies of natural gas were found under the city, therefore putting a damper on further solar development. Our nation has always relied upon fossil fuels to meet our energy needs. They were always cheap and abundant. Today, however, those once cheap and abundant supplies of fossil fuels are becoming harder to find and are much more costly. By using the sun's energy, we can bring to a halt our fears of a foreign oil boycott. And perhaps, most importantly, we can enjoy an environment that is pollution-free. The basic function of any solar system is the collection and conversion of solar radiation into usable energy. To explain this function to you, let's take a look at this chart and explain the basic points of how a solar system works. Heat from the sun is absorbed by collectors, is transferred to storage, and distributed to points of use. To begin discussing these components with you, let's go to the Club California apartments in North Hollywood and show you some collector installations. It is important that collectors be placed where they will receive the most sun. Ideally, this is true south with deviations of 15 degrees either east or west deemed acceptable. A roof mounting like these here is the most common placement for collectors because it reduces the chances of shading and keeps them out of the way. If a good roof area is not available, collectors may be mounted off the ground or may even be incorporated into the wall of a home. Collectors which are added to existing buildings, called retrofits, should be raised a minimum of 1.5 inches off the ground to avoid damage to shingles. This will also prevent mold and fungus growth. It is also important to place collectors where they are free from the damming of snow and ice, and additionally away from heavy wind areas. If more than one collector is used to capture solar radiation, a minimum of 1/4 inch space should be allowed between them to allow for contraction and expansion. Of all the presently developed collectors, the relatively simple flat plate kind has found the widest application. Its distinguishing feature is just what the name suggests. Energy from the sun is absorbed by a flat plate. Flat plate collectors fall into two categories. They are either liquid types or air types, depending on the transfer media that carries to distribution or storage the absorbed heat. The collectors at Club California are liquid types, as is this cutaway of a flat plate collector here. The first thing you will notice is the absorber plate. It is coated black to increase absorption of the sun's rays. The cover plate, made of tempered glass, and the insulation here help trap heat within the collector. Heat is transferred this way. Imagine this being the top of the collector. Cold water enters here, runs down the header, and goes down these corrugated metal tubes, which absorbs the collected heat. Usually, flat plate collectors have copper tubes attached to them to carry off the absorbed heat. This flat plate collector, however, has two pieces of stainless steel which are welded together. Heat, which is collected by collectors, can be distributed directly to the home or it can be stored for later use. The storage medium, then, is an important part of the solar system, since there will be days when the sun doesn't shine. Two commonly used materials for thermal storage are water and rocks. A third storage medium, phase change, is in its infant stage. Water storage is not only the most inexpensive of the storage mediums, it also has the highest heat capacity per pound of any ordinary material. Water storage tanks are capable of supplying both warm air and hot water to the home. The major drawback to water storage is their destructiveness should they leak. Rock storage is used almost exclusively with warm air space heating systems. As you can see in this diagram, warm air from the collectors is blown through a bin of rocks which store the heat for household use. Rock storage bins are 3 times larger than water storage using the same size collector. Therefore, there is a problem of finding adequate space for this type of storage. Like all storage mediums, rock storage, where at all possible, should be located in the center of the dwelling. The third storage medium, phase change, stores and releases heat by a process of melting and freezing. This is accomplished by using such chemicals as Glauber's salt. One of the advantages of this seldom used material is that it stores up to 9 times more heat per volume than water. The long-term reliability and the expensive containers they must be kept in make this storage medium at the present basically unreliable and untested. The organization of components into a solar heating and domestic hot water system has led to 2 general characterizations of solar systems, active and passive. The terms active and passive have not yet developed universal accepted meanings. Nevertheless, each classification possesses certain characteristics that are distinctly different from one another. An active system can best be described as one in which an energy resource, in addition to the sun, is used for the transfer of thermal energy. In this example, water is circulated through the collector by means of a pump located near the storage tank. As you can see, the collectors on this home are flush with the roof. This is acceptable on new homes, but not on existing homes. A passive system relies on natural, non-mechanical means to collect, store, and deliver heat. This beautiful home, designed by architect Mike Barsocchini of Malibu, relies mainly on large south-facing double-pane windows to collect heat. An attached greenhouse is another concept for solar collection. 2 other concepts for passive systems are large cement floors and masonry walls, which can store large amounts of heat. Deciduous trees are used to block out the sun during summer months and let the sun shine in during the winter. When the builder is computing the efficiency of a solar system, whether it be active or passive or a combination of both, he should take into consideration the life expectancy of the system, the initial cost, and the cost of accessory heating. That finishes our program on the basic components of a solar system. A brief question and answer session will follow.
This is the portion of the program that we've set aside to review some questions. You should have a workbook that looks something like this. If you haven't got it handy, take a moment to get it out and turn to the questions section, and we'll begin right away. Collectors mounted on roofs in retrofit installation should be placed where? Facing north, which is your A choice. B, to avoid the damming of snow and ice. C, flush with the roof. Or D, none of the above. Your proper answer should be B, to avoid the damming of snow and ice. Question number 2. On retrofit installations, collectors should be placed off the roof at least how many inches? A, 1/2, B, 1 inch, C, 1.5 inches, D, 2 inches. Your correct answer is C, 1.5 inches. Question number 3. Ideally, collectors should be aimed as near as possible to where? A, B, C, or D? True south, magnetic south, due north, none of the above. Take answer A for question 3, true south. Question number 4. In multiple installation, collectors should be placed at least blank apart to avoid contraction and expansion. The proper answer here is B, 1/4 of an inch. Over to question 5. The storage medium that has the highest heat capacity per pound of any ordinary material is A, rocks, B, black steel, C, water, or D, none of the above. Your answer here should be C, water. C, water. Question number 6. Water stores up to 9 times more heat per volume than phase change materials. True or false? The answer is false. And I'll tell you why. Phase change stores up to 9 times more heat per volume than water, so it should be, as you see, just the reverse. If you want to make a little note there in your workbook, remember this is your workbook. If you want to draw in it and make notes as I give you explanations, something to help a memory response when you're taking the examination, please feel free to do so. Question 7. Phase change is a storage system that stores and releases heat by the process of melting and freezing. True or false? Well, if you remember from the program previous, you would answer that true. Question number 7 should be answered true. Number 8, the ideal placement of a storage system is A, outside the dwelling, B, near the bathroom of the dwelling, C, the center of the dwelling, or D, none of the above. The proper answer here should be the center of the dwelling. We're on question number 9. Heat is distributed to the home either by warm air, hot water, or both. True or false? Your answer is true for number 9. Number 10, passive systems employ the use of pumps, fans, or blowers to collect, transfer, and distribute solar heat. True or false? Question 10 should be answered false. Passive systems use no mechanical devices in collection, transfer, and storage of heat. Passive systems rely only on the sun's energy. If you'd like me to go over that again for you, if you're taking notes, question 10 should be answered false for the following reason. Passive systems use no mechanical devices in collection, transfer, and storage of heat. Passive systems rely only on the sun's energy. 11, in computing the efficiency of a solar